Welcome back, chemistry fans. We are going to go over the solution to the unit. I believe this is 11 heat quiz. It's not really a test. So we've got 4 questions on this one, and we want to go over those right now. So let me share my screen, and then we'll get started on those. Okay, so here is the first question for you. It is complete this reaction. Basically, we want you to be able to predict the products and then tell me what materials are going to be cut out and removed. Before we do that, we do need to consult a solubility curve, solubility chart. And so let me get those list of rules there because they are going to be important for us as we move forward. So let me bring those over and put those on a new sheet. I should have done this sooner. Forgot to do that right now. All right, so now we have the solubility rules that we can consult when we get to the point where we are needing them. All right, so let's jump back into the questions. So first off, we have to recognize that there are no materials by themselves. That makes this one a double replacement. So the metals are going to trade places. So I'm going to have Cu now with the S. I've given you the charges, so it is already balanced, +2, -2. And then also you're going to have sodium and nitrate. Again, already balanced. However, there are 2 of each of those, meaning that there needs to be a 2 in front. Now, what we need to do now is figure out what states of matter these are in, if they're soluble or they're insoluble. So that's where the rules chart comes in. And look, all of our nitrates are soluble. That means they are all aqueous. And then if we look down here, our sulfides, they are all going to be insoluble. They're going to be solids. There's no exceptions dealing with copper in that scenario. So what we have here is that we have aqueous copper, we have solid copper sulfide, and we have a aqueous of the sodium. Oh my gosh, I keep getting worse on the S. There we go. On the sodium nitrate. Okay, now one of the skills of this one is being able to show the dissociation of each one of these compounds. So we would have to write out the sodium is being split apart, the sulfur is being split apart, and they are aqueous. And then the copper +2, it is also aqueous, and they tell us that. So nothing so far has been new that I am writing down. That's all information that's in that starting point. I'm just separating them. And notice how it's not 2 NO3s. It's 2 NO3s. It's not NO3 with the 2 outside, because when they become ions, they separate into different particles. They don't stay together. All right, then the CuS, it does stay together because it was a precipitant. No charges are necessary to be written with it. And then finally, we have then 2 NAs, which are ions. Whoops, should be 2 over here as well. And they are aqueous. And I have 2 of the NO3s, which are also aqueous. So at this point, what we got to do now is cancel out the like terms, the sodiums that are aqueous, as well as the nitrates that are aqueous. And that leaves us with our answer right there. Sulfur plus chlorine, both aqueous, produce copper sulfide, which is a precipitant solid. All right, so moving down to question number 2. Predict the charges of hydrogen, carbon, and oxygen. So we've got 3 elements, but the total charge is -1. I do know that every single oxygen has a charge of -2, so that's a total of -8. I know that I have a rule that says that every hydrogen is +1. So we've got to figure out what are the charges of the 2 carbons that are in here. So if I combine those 2 values together, I have a -7 plus 2x equals -1. So now what I can do is I can combine together like terms. And so I would end up those being canceled. So I have 2x is equal to 6. That means my x is equal to +3 for the carbon. All right, moving on. Number 3. So now I want you to write out who is the oxidizing agent, who is the reducing agent. So what we got to know is that any elements by themselves are 0. So this element, gold is going from a +3 to a 0. That's becoming more negative. So it means it is gaining electrons. So if you gain electrons, that means you are being reduced, meaning that you are the oxidizing agent. And that's what it is asking for. Now, we can go the other route and we can prove that -1 is going to 0. And that means that it's becoming more positive. That means it's losing electrons. That means it went through oxidation, meaning that this is my reducing agent. All right. Now for the final question, number 4. Let me blow this up so we can actually see the question. And what we're asked to do here is to balance this redox reaction. So what I've got is MnO2 producing Mn. That's one of my half reactions. The other half reaction would be aluminum producing aluminum ion. Now, the aluminum is already balanced by the elements. The manganese, it is not. It's missing some oxygen. So what we're going to have to do through the steps, the process of fixing this, is we are going to have to add 2 waters. We don't just get to add oxygens. In doing so, what we've now created is an unequal number of hydrogens. So I've got to add hydrogen ions. But now what I've got is an unequal number of charges. So I got to level that out. So I've got to put 2 electrons here because -2 and +4 is +2, which is the same as the charge on the manganese. So now we're all good here. But the aluminum, there's nowhere for us to add hydrogens to balance this out. So what we're going to do is we're just going to add 3 electrons. Now, 3 and -3, that equals 0. Both sides are equal. Problem is, my electrons are not equal. So I need to multiply everything in there by 3, multiply everything on this half reaction by 2 to make both of those 6. Now my electrons would cancel out, but I've got 12 hydrogens. I would have 3 of the manganese, 3 of the manganese ions, and 6 waters. I'd have 2 aluminums, and I'd have, again, those 6 electrons. So now we sum all this together. 6 electrons, 12 hydrogens, 3 MnO2s, plus 2 aluminums produce 3 manganese ions, 6 waters, 2 aluminums, and 6 electrons. The only thing that's going to be canceled are the electrons. This is your final answer. All right, this is everything that I hope that you would have achieved on your quiz to demonstrate that you have mastery over redox reactions. Thank you very much. I will talk with you again soon. Farewell. Bye.